So in this video, hopefully just this video, but we'll see if it extends onto another part 4, we're going to talk about parametric, polar, and vector functions. So, and like how to take derivatives with them, or like eliminate parameters or change to Cartesian or whatever. It's not too bad, but we definitely can use some practice with the polar stuff. So, what do we have? Parametric curves are defined, we'll start with parametric. Defined by functions x and y. Both are functions of t, and t is called the parameter. That's why they're parametric equations. You can think of t as time, usually. So x, the x of t, the x function, represents the x-coordinate of a single point. And then the y function represents the y-coordinate of a single point. Depending on what value of t you put in, the x-coordinate changes and the y-coordinate changes. So you can get these kind of like interesting curves just based on these two parametric equations. So that you normally couldn't get with just like a function y defined in terms of x. So they're each functions on their own, but they represent the x-coordinate and the y-coordinate. T usually you can think of as time. And then there's some questions where you would have to, given two of these equations, find an equation that only involves x and y. That's the Cartesian equation for the same kind of curve. For some curves like this, you can't easily find a Cartesian equation because this is not a function. That's not a function. But sometimes you can have like something like that. That is represented by the parametric equations, and then you could easily find, that's just a parabola, you could easily find a Cartesian equation for a graph that looks like this. For these ones it might not be so easy, or it might be impossible to find an explicit Cartesian equation. But we're going to look at how to find a Cartesian equation given two parametric equations. And what that involves is eliminating the parameter, so getting rid of the t. So you get rid of the t first, or that's the goal, because if you get rid of the t, all you have is x's and y's, and that's a Cartesian equation. There you go. So the first step so the goal is to eliminate the parameter t. So you only have x's and y's, I said that already. Solve for t in one function, substitute it into the other function. That's the easiest way to go about it. So that's what we're going to try with this example right here, right now, right now. Okay, so I'm just going to pick one of these and solve for t, and then I'll plug it into the other. So I see that I have y equals some stuff. Now, normally my Cartesian equations are y equals something involving x. So what I'm going to do is I'm going to start with this one, and hopefully you'll see at the very end. But again, I'm going to solve for t. So that's the first thing that I'm going to do. And that means I'm going to subtract 2, and then I'm going to take the natural log of both sides. Because anytime I have a variable that I want to solve for, and it's in the exponent, I can use logs to get them down. So that can move out front, but the natural log of e is just 1. So that gives me t on that side, and then ln of x minus 2. So that's what t is, ln of x minus 2. So that was the first part, solve for t. Substitute that into the other function. And so I have y equals e to the 3t, and I'm going to say that that's the same thing as y equals e to the t raised to the 3. That's definitely the same thing. I think that'll simplify things a little bit. Hopefully you can look ahead, think ahead, and figure out why I'm doing that. But then I have e to the t, which is ln of x minus 2, and then all to the third. Now, see, that's why I did that, because that cancels out, and I just have y equals x minus 2, because that simplifies to x minus 2 and raised to the third power. Here's something to note. This is what I was saying before. You can get some like crazy looking functions with parametric equations. This is a Cartesian equation, but notice that when I solve for t right here, I can't have any negatives on the inside of the log, so that restricts my x values. It restricts my x values for the parameter t. I can't have any x values that are less than 2. Or sorry, more than 2? Yeah, less than 2. Because then it would get a negative on the inside of the natural log. That's just saying here, I can't have anything less than 2. Nothing will come out that's less than 2, no matter what t value, negative or positive. So this part, I can see that x is restricted, so that means the domain here is 2 less than 2. I can't have 0 either because that would ruin the natural log. So the domain is from 2 to infinity. But that's how you find the Cartesian equation. That's how you eliminate the parameter. It's just those steps right there. Hopefully that's pretty simple. Maybe I'll move this into another video.